with about 10 years of experience. And today I'm running through the Latterly LeetCode kata. You can sign up to Latterly for free at latterly.io and unlock an advanced checklist for as little as $1 a month, more features if you go premium, and then you can do one-on-one expert sessions with a job guarantee and deferred payment and stuff like that. So how do you get to this Latterly LeetCode kata? You go to the blog. So the blog is in the upper right. It's article number 3. And this is a minimal set of software engineer coding challenges from LeetCode. It's only 12 in the standard kata, which is far less than the blind 75 or the grind 75. And yet, even though it's only 12 questions, it will prepare you for 2/3 of expected interview questions. So that's the virtues of this. It's a warm-up tool. You can read more about it here. It's not a substitute for other styles of learning like deep learning, but it is a complement. And there's a section about the historical guidance as well. Okay, so it's not replacing the historical guidance, it's building on top. So the standard kata is listed right here. So the first question is 2 sum 2. I'm performing it for you. And I yesterday did the first performance where I got through 2 questions in about 40 minutes with about, I don't know, 10 minutes of context and stuff like that. So we're keeping the context shorter today. Although I will say the TikTok shop is up now. So you can get the, let's see. Oh, it doesn't let you view it on the web. That's a bummer. But anyway, if you, it showed my live on the web. That was cool. But if you go to the Latterly shop, it's currently not all the way implemented. Okay, and you can see the headband in the top left there. But the TikTok shop is implemented. So you can get the Code is Magic hoodie, the coding season long sleeve, and the iCode and Caffeinate cap, as well as the Chibi sticker set is all in the TikTok shop. So that's all the promotion I'll do. And then we'll dive into the kata itself, starting with 2 sum. And this is 2 sum 2 with the input array sorted. So we want to use the 2-pointer method. Clear out the body here and let's write it. So I know that I am doing a 2-pointer method. So I want to go ahead and set up the left and right pointers. So I'll initialize the left to 0 and the right to the maximal index of numbers, which is going to be length of numbers minus 1. And then I want to do a while loop. So I'll say while left is less than right. And I think I can do less than right minus 1, but I'll leave that alone. I don't know that it makes too much of a difference. And eventually we will return result. It's always good to ask what is the shape of the result, and we also want to remember the target time and space complexity. So target space complexity is O of 1 because I don't need to store anything because we're going to use the numbers as they are. They're already sorted. And the target time complexity is O of n. Let's see. Yeah, just a single pass because again, I'm using a sliding window and I only need to look through the numbers 1 time. We know that this is a 1-indexed array. So this is a little bit, depending how they ask it, this is a little bit unusual. So the result is going to be, we're going to add 1 to the indices. Okay, so this will be the final left index plus 1 and then the final right index plus 1 because they want the 1-indexed form of the result. And again, because it's a kata, I've done this so many times, I happen to know that there are going to be 2 return locations. One inside the while loop and a certain condition will go ahead and eagerly return, and then the final at the end. So what are the conditions here? What we want to do, we need to get the actual left and right value. So I can say left value, right value. And I could, this is often just called left and right, but to distinguish it even further from the index, I like to name it that way. And so what this is the left index of numbers and then the right index of numbers. Okay, so we want to compare to target. So I need the current sum. So the current sum is the left value plus the right value. Kids just got back. So if the current sum is less than target, else if the current sum is greater than target. And then that'll be an elif in Python. And then else, which is equal to target. And so in this equal to target, that is the case where we are going to eagerly return. Does that make sense? Okay. All right. So if it's less than target, we already have the upper bound as far as we can go. So we cannot move the right pointer to the right to increase the total sum. We need to move the left pointer to the right. Okay. So left index plus equals 1. And then in this case, right index plus equals 1. And that should be our two sum. Okay, if I've typed things correctly. List index out of range. Let's see. Do I need to do that? List index is still out of range. Numbers, right index, length of numbers minus 1. Right IDX is the length of numbers minus 1. Let's do some print statements. Why would this be out of range? Right IDX. We got 3 and 4. Am I moving the right index to the right? Oh, yeah, okay. That's dumb. I should be moving my right index to the left. Cool. All right. So with the window, we're moving the right to the left and the left to the right. And that's how we're restricting the window to find if there's ultimately an answer in the middle. Okay, so, and I don't really think I need that extra one there. Let's see. So we'll submit. Cool, and we are at 7-minute mark. So we shaved a minute off from last time. What's up, chat? Sliding window, you got it. Shaved a minute off from last time, so we're doing so far so good. Again, the target there is you want to solve in 5 minutes, but I did some amount of context up front. I didn't really time that. And if we don't solve it in 5 minutes, we're looking up the solution. Okay, so now let's go to the next problem in the kata, and that is 3-sum. And the idea here is to create a pattern level flow. So you go from 2-sum to 3-sum. That's one of the benefits of the kata. So I will chop off the body and I'll leave this top comment. I'm reminding myself with this top comment that I want to implement both solutions. There's a no sort solution and a 2-pointer solution. And then as part of the kata, I want to say some things out loud. It helps it drill it into memory. What I want to say out loud is, the 2-pointer method is preferred because of the lower memory requirement. So why would I ever use no sort? The only time I would prefer no sort is if I'm explicitly not allowed to sort. The conditions of the system do not permit me to sort. For example, you might see this in dynamic systems where you're not getting an array at one time. You're getting values over time. So I literally can't sort. And in that case, I'll use the no sort method, which leverages a hash. That would be at the system design level equivalent to like a Redis or something. Super, super powerful pattern. But if possible, 2-pointer method is more efficient, not because it has better time complexity. They're going to have the same time complexity, but because it has a lower memory complexity. So that's one of the gotchas people forget with this question very often. A lot of times, leet coders will be paying attention to the time complexity and just forgetting about the space complexity. Okay. So I'm going to go with the less efficient form first, which means I'm going to go for no sort first. For me, this is really difficult, and maybe I shouldn't do this. Let me go for the 2-pointers first. 2-pointers has a better flow to it because we just got done with sliding window, and 2-pointers is a sliding window. So we can address the no sort option as yeah, the trick is in an interview setting, you want to make it work and then make it work better. So what's better? They just start off with no sort in or 2-pointers in the editorial. What is this? I think it's fine to go straight for the 2-pointers here. And the reason is we can sort it, which is not going to slow down the time complexity. So sort is going to be n log n. And the time complexity is n squared anyway, so it doesn't actually change the worst case asymptotic time complexity. Okay, so target time complexity is O(n) squared. That's not quite notation. I should use the caret or whatever. Target space complexity is O of 1, just 2 pointers. And that is ignoring sort requirement. Okay, so the sorting subroutine would have some memory requirement, but we are not implementing that by hand. So we have the time complexity, the space complexity, and this is assumptions. I can sort. We'll use, or this is like general strategy. General strategy. Sort doesn't slow down from n log n. Okay, and general strategy is sort. And why am I doing this? Why am I not just going into the code? Because I want to emulate a real interview. And I would be walking through all of this in a real interview. Is the AWS cert worth it? Depends on where you're at, but it's one of the more valuable certifications. Yeah, Certified Solutions Architect. It is. It does have objective value. Yeah. Thank you. Did you warm it up?
Yeah.
Thanks. I don't like Sam yelling at you.
I know.
Okay.
I talked to him about that. He's calm.
Okay, cool.
He's all right.
So we sort and then simply wrap two-sum in an O(n) pass. My company is paying for it. Awesome. We love that return on investment. Get your company to pay for it. All right, y'all. So let's get back to the problem. So we don't really implement the two-sum as a helper. We implement the two-sum in band, which is kind of weird. If I was writing real software, I would break it out into a helper, but all the solutions have it in band. So let's do that. So what I'm going to do is for key, let's do key value. Why not? And enumerate. I don't know that I need the key and the value. That would be the index and the value, and enumerate nums. And here we're simply going to wrap. So what I want to do is have a scene dictionary. Really, it should be a set, but I don't want to be thinking about that too much. What are you hacking? We're just doing some LeetCode, so we're doing free sum right now. You can read that. So we're going to do scene because we can't pick up duplicates. What else are we going to do? Maybe duplicates should be their own thing. I think I've typically seen that as a set. Okay, so I get into here. Oh, I need to sort it because we're doing 2 pointers, right? Yes, we're doing 2 pointers. So nums.sort. Okay, so now that we're sorting, I can just do the 2 pointers in here. So I don't even know that I need the index now. Oh, I can have results. Results is also a set because there can be multiple. Okay. So results dot add is something we're going to do. We're going to do the sorted tuple. Cur result is the sorted tuple. And why do we want to use a tuple? Because it's hashable. We want to use a tuple because it's hashable. So this is going to be val, and then I'll call this wrapper val. Thanks for the rose. We'll call this the wrapper val, which is we're in the 3-sum loop, and then there is the 2-sum left, 2-sum right. And in many solutions, you'll just call this scene called value 1, 2, 3. I hate those variable names. Really hate them. So you can see we have the wrapper value and then the 2-sum that we're doing right here. And we're going to add the current result, which is a tuple. And we're going to do this if we get a target of 0 from 2-sum left and 2-sum right. So we just say target is 0. and we can go write two sum over here. So here we're going to do for left value right, while, just like what we did. While left index is less than right index, just like what we did with the two sum sliding window. Okay. So while the left index is less than the right index, we're going to set left index equals 0, right index equals, and this is the part where we need to leave out the duplicate. We can still start it on the far right hand of nums, and then we'll just skip duplicates. Nums length nums minus 1, okay? So now we'll get the left value. Left is the left index of nums, and right is the right index of nums, okay? If left is equal to right, or left in duplicates, and this is why duplicates can be a set, great, or right in duplicates, we're going to continue, okay? Is an MS in computer science worth it? Yes, it's one of the best degrees you can get. Fantastic degree. Okay, so if there's a duplicate value, we're just going to skip this set. Now, I need to make sure I also add them into duplicates. Okay, so here's what I can do. I can break this into two if statements. So if left in duplicates or right in duplicates. No, this is fine. We'll still continue. I'm handling the duplicates wrong. This is bad. Okay, so I'm going to go ahead and do this, but I think this is wrong. I think this is wrong. We'll add them both, and then we'll continue. Add left and right. I think this is wrong, but I'm doing it anyway because I can't think of the right thing to do. Okay. So now that we're saying that there are no duplicates, we are going to compare the values to target. So if, then we get the cur-sum. Cur-sum is right plus left, okay? If cur-sum is less than target, elif cur-sum is greater than target, else. Else we return. So here I'm just calling this left and right. We have the wrapper value left and right. We want them all to add to 0. So what is the target? The target is the opposite of the wrapper value. Because that way they'll all add to 0. Make sense? Okay, great. Thanks for the follow. Let me make sure I'm not ignoring the YouTube chat. Oh, we have YouTube chat. Muslim says, hey, John, that's on LinkedIn. Hey, how's it going? Good to see you. So here, and we want to move the pointers. So if the current sum is less than the target, then we will move the left index. And if the current sum is greater than the target, then we will decrement the right index. Cool. Move that over and continue. Then we stack up our results. There can be more than one answer, right? And I think we're good, except that I handled the duplicates wrong. So let's check it out. Wrapper value is not defined. Did you mean wrapper val? I sure did. You make me want to code again. Chalky Milk, what's up, gang? Thanks for being here. That's good to hear. I love to hear that. Time limit exceeded. Okay. Probably because I'm handling the duplicates wrong. All right, so we cooked a little bit, but we went over our time box. So let's go look at the answers. So what we're doing is the two-pointer method. All right, so we got the correct, time complexity and space complexity. Sorted, right? Iterate through the array. Good, we're doing that. Oh, if the current value is the same as the one before, skip it. This is what we're missing. This is what we're missing. And this is causing us to exceed the time limit. All right. And they did break out 2 and 3 sum. How did I not see this the other day? I'm so glad they did that. Wait, do they do that for the no sort as well? They don't. They don't. Okay. Well, there's 2 things to improve. Remember, the cup is half full, gang. The cup is half full. Thank you for the likes. Okay, so the first thing is that we do want to break out the 2 sum in the sliding window case. For some reason, we don't in the no sort case. I'll have to think about that some more. But okay, we sort. We go through the range instead of the enumerate. I don't know that that's a big deal. If nums is greater than 0, break, and that also saves us so much performance, okay? Not worst case performance, but average and best case performance. Because if they're sorted, the minimum is greater than 0, you're not going to have any set. You're not going to have any set. And then they set up the base case better, which I didn't do. All right, so let's implement. Well, I did this. I think it works either way. Yeah, I think you can have results as a set or as a list. I think the set is more efficient. Okay. So let's implement the answer. Just looking at it is not enough. Remember, kata is a mind-muscle connection, like martial arts. You have to go through the motion and do it. It's going to help you learn, believe it or not. You feel like you're just repeating something you're told, but it's actually going to help you learn because you're innately going to be questioning and resisting as you type everything. But as you can answer that, you break through those resistances, those micro resistances. So after we look, we want to review, and then whether or not you understand it, we want you to write it. We want you to write it. So do I want to write it from the top down, or can I just sort of retool this? So I noticed that I don't have a scene map. And I noticed that I don't need to explicitly have a duplicate set in this approach because we are going to be breaking out within the loop. I do have results. It's a set, not a list. I'm going to keep the set, and if the set fails, then I will change over to a list. But I think the set is going to work anyway. Okay, for index and wrapper value. They look up the ith index multiple times. So actually, I'm going to say that mine is better than theirs because they are looking up the ith index on nums multiple times, where I just have the value here. But this is equivalent in spirit. Okay, if nums, this is the part that I'm missing. If wrapper value is greater than 0, break. So that's an important guard clause that I was missing. Let's see if that alone is not going to fix it. I don't think. Duplicates is not defined. Okay. Yeah, I handled the duplicates wrong. Okay, so we have this guard clause. Then if I is 0, if I is 0 or nums. Okay, so this is where they're checking. This is where they're checking that we have changed from the left hand. And we only need to change on the left hand because now we're having a sorted and we're moving left every time. So it's almost like a, excuse me, hiccup. It's almost like a 3-pointer method. And we're checking that third value has changed. The wrapper value has changed. So I can also hold a prev if I want to. But they don't, and so I won't. They don't, and so I won't. Prev is, so I'll calculate it just in time. Prev is nums idx minus 1. And I'll say if wrapper value is not equal to prev, then we're going to go through with twosum and we're going to break out twosum. If wrapper value is not prev, we will call twosum. On nums wrapper value, let's see. I just need 2 arguments, is that right? Nums and the opposite of wrapper value. Self nums list. Oh, I need the result because I'm going to append results. Okay, so I need the list of numbers. I need the target, which is going to be the opposite of the wrapper value, and then I need the result set just so that I can append. This makes sense. And what about the else case from this? And I can have that comment up here, and I don't need the target there. Okay. Otherwise, we are looking good. We just need to break this while loop into its own helper, which I actually prefer anyway. Okay, so here we have 3sum. And here we'll define 2sum, which is going to return nothing. Because it's going to, no return, because we modify results in place if needed. Okay. Thank you so much for the likes. Over 25, we're going for over 2,500. Thanks. Okay, and so the arguments here are going to be self, nums, and target and results. Nums, target, results. Good. We'll dedent this. Okay. And then we're going to set up our left and our right over here. Bummer that we're recalculating left and right, huh? But they are trivial calculations, so it's okay. Actually, we can pass. We can pass them in if we want to, but whatever. Let's pass them in. I don't like recalculate. Let's not. Let's keep it isolated. What do? They have low and high, so they basically recalculate it. Oh, I'm not using it at all here. So it's not a recalculation. I can just move it. Good. That makes my heart happier than recalculating. Okay. Wow, we're going on 3K. W chat. Thanks, y'all. Okay, so we have the left index and the right index. And what we're doing is we're still abusing our duplicate check. Great. So how do they do this? They do the one-liner. I don't like the one-liner. Let's break it out. So low. We don't need to check the 0 index. That's right. That's right. Fair enough. Never need to check the 0 index. Fair enough. And then that should go down here. Never need to check the 0 index because that'll be handled in the wrapper. Thanks for the follow. All right, and then for the right index, that is set up properly equivalent to what they do. Okay, and so while left is less than right, they call it low high. Fine, I actually like left and right. That's fine, but it's the same idea. And then they have the current sum. Okay, so they go ahead and calculate the current sum. Fine, makes sense. If the sum is, so they go right into it. If the sum is less, if the sum is higher. So there's no duplicate check interior. Really? There's no duplicate check interior. I guess because the calculation is so trivial. Because the calculation is so trivial that like you've gotten this far, there's just not that much advantage to duplicate checking over here. So there's no duplicate check at all. Okay, fine. It's definitely not theoretically needed in the worst case asymptotic analysis. Although I was getting the timeout, but you know, that's only a micro optimization basically. It's funny how in LeetCode sometimes micro optimizations are needed, but that's fine. So we have the left, the right, the current sum, increment, decrement, and then we add to results. Cool. And you could return there and make it functional and not pass in results and have it returned. But that's not what they do, so that's not what I'm doing. ToSum is not defined. So how about self.ToSum? Selfed is not defined. Yep, that makes sense. Over 3,500. Thanks so much. Wrapper val is not defined. Where is it? Wrapper value. Oh, okay. How do we handle the writing the results? So res append nums I low high. Oh, okay. They pass in the wrapper integer. That's very smart. That's very smart. Never need to check. That's very smart. Never need to check below the ith index. Okay, so I missed a critical argument actually. I don't need to pass in the target at all. I just need to pass in the wrapper IDX. Okay? Target is the opposite of nums wrapper IDX. So I can reestablish the target right here. Can reestablish the target right here instead of passing it in. But I need this index. And the reason I need this index is because it makes me check much fewer. It makes me check much fewer pairs. So that's going to save a bunch of computation. That's really critical. I'm glad that we reviewed the answer because I don't think I would have thought of that on my own. Okay. And so here, do I have access to the wrapper value? Yes, I do. And in fact, if I'm going to, so I can recalculate it right here. So and I generally prefer longer, clearer, more verbose names. I know it's a pain in the ass when you're leet coding. You want to save characters and save time, but if it's just going to drive me to misspell things. I is not defined. Did you mean capital I? What? No, I meant this. Sorry. I meant this. Unhashable type list. Right. Right. Where is the list coming from? Cur result is a tuple. Thanks for the follow. Why is this giving me unhashable type list? Cur result is a tuple. Results is a set. I'm definitely missing something. Okay, so let's look at the no sort, because the no sort uses sets. Here's res add tuple sorted. Oh, I didn't use the tuple keyword. I just thought the parens would give me a, okay, because sorted is returning a list. Sorted is returning a list. That's the issue. I thought because I was using the parens here, I'd be good. Must cast because tuple, must cast because sorted returns a list. I thought I could sort the tuple. All right, fine. Expected one argument got 3. You can't add a list on a set. It's unhashable. Right. Yes, a list is unhashable. Yep. Okay, sorted expected one argument got 3. Why does sorted expect one argument? Oh, yeah. So we can sort the tuple. And it's sorting the tuple to return a list. That's kind of strange, isn't it? So we're doing tuple, sorted, list, tuple again. So that is not cool. So I wonder if that's the reason that we're getting a timeout. So let's do, can I just do like this? Expected one argument got 3. Let's keep it listy this time. Unhashable type list, fine. So we're going back to tuple again. Right. Okay. So yeah, the set's not going to work. Chat says, I told you it's unhashable. Yeah, I know it's unhashable. Unhashability was never the question. The question was performance. So it actually did. I don't know if you noticed, it actually did enter into the set, and then I just got a timeout error. So the part that's surprising to me is that lists are more performant than sets here. That actually is surprising to me. Well, this one's taking a long time too. Memory limit exceeded. Okay, I think I'm missing something. So whether we use a list or a set, we're getting different sorts of errors. What's the difference between a list and a set? The set is not going to have duplicates, and the contents of the set are hashable, and those are related concerns, right? It automatically dedupes because when you throw it in the set, it calculates the hash key, and then it overwrites whatever is there. So a set is nice for making sure you don't have duplicates. Your break condition is the problem. Oh, okay. Well, I don't know if I wrote a break condition, but maybe that's exactly the problem. If nums I is greater than 0, break. And what's my break condition? Oh, did I just say continue? Suresh, how's it going, Suresh? Thanks for being here. This seems equivalent, huh? I mean, does it need to be on a different line? Or are there 2 break conditions? Something is different here, it looks like. So I think that break condition is equivalent. But something is different here. Okay, so res append. Oh yeah, there's no, let's see. There's no need to sort it at all. That's a good point. There's no need to sort it here at all because we already know. We already know. Let's see. We already know that the wrapper value comes first and then the left and then the right. Append takes exactly one argument. Okay, let's turn it into this. So this while bit is the piece I think that's missing. And this is going to, yeah, this is going to skip over duplicates basically. So that's how we're doing better. So while we're here, while low is less than high, so there's an inner while loop. That I'm not expecting. This really saves me what? This just saves me the addition calculation. Really all this saves me is the addition calculation. That's kind of crazy, but let's do that. Why are we moving both pointers? Why are we moving both pointers? Ooh, I really don't get it. Why do we get to move both pointers? Because if we move only one, there is guaranteed to be a duplicate. If we move only one, there is a guaranteed duplicate. So this saves us some performance. So this is not going to change the worst case complexity. This is like a micro optimization, but apparently it's one that's important enough that it makes the difference between timing out and not. Okay, so that's why we only move one. Good, I'm glad that clicked. Oh, Christian doesn't have audio. It's threesome. It's threesome. Okay, so here we can look up, we basically do a nested, we can do a nested two-sum. So we get left, right, the current sum. We get left, right, the current sum. And while left is less than right, left is less than right, and there should be a res append call in there, no? Oh no, it'll just continue through to the next one. And nums low is equal to cool. So we're just moving the left pointer inside. We're just moving the left pointer inside. We'll call LMNOP priv. Ensuring no dupes by moving left. Unexpected indent. Oh no, the worst thing in Python. Is that meant to be flat? So we have the results. Yeah, it is. Okay. Okay, and results here. Here is where I'm curious. Can I do, now that I've done those changes, can I do a set after all? Because it will be nice to me if I can just always do a set.
I'm gonna start getting them packed in the car.
Okay. Are you sure? Are you see the other solution in live? Yeah, I see the other solution. Output expected. Let's see, nums 0, 0, 0. Isn't that duplicates? Okay, they're duplicate values, but not duplicate indices. Okay, so that is a big miss on my part. Why would it be? Yeah, where am I doing this check? Sir says, are you a beginner in coding or doing practice? I'm doing practice. I've been coding for about 10 years.
Where's mommy?
She went to the car.
But I want to go to the car.
You want to or you do not want to?
I want to.
Okay, she'll come get you in 2 minutes, okay? Bye. That's Ellie. Yeah, when am I doing? So this is what I'm doing here, right? Is that collapsing somehow? Let's switch it back to a list and see. That'll be interesting. It's like collapsing this. It's like collapsing this group somehow. Okay. I'm glad to see that didn't make the difference. So where is the difference coming from? Target is the opposite of the wrapper value. So the wrapper value, let's step through. Okay, so I have nums, which is a triplet of zeros. Is it this? If wrapper value is greater than 0, break. It should not be that. So we can confirm that we get okay. Maybe the issue is that this doesn't work. Yeah. So I'm doing something different. I'm doing something different right there, where I need to skip the first one, basically. Thanks for the follow. If I is 0, yeah, this is the part that I'm missing. Okay. So how do we handle that 0 case? Okay. So if I is 0, we're not going to check priv. There is no priv. Because it's out of bounds. All right, cool. And so it does work whether it's a set or a list. It still works. Well, let's see if it times out. But if it times out, I would be surprised if it times out on a set and not a list. All right, we made it. Ooh, we got really good. And let's check this, okay? Although it's slower somehow. That's crazy. So are we using more memory with the set? Let me resubmit that. I wonder how much variation is to blame here. It looks like I previously submitted. Oh, JavaScript is way faster than Python at this. That's wild. You got your shoes on? Yay. All right, let's check it, turn it over to list, but we're basically done now. Whoa, what? Because those are duplicates. Okay. Duplicate values are allowed, just not duplicate indices. Just not. Interesting. So I can use the set and that'll inherently dedupe it, but I wonder if this is a smell that there is some logic that I'm missing. I could have a scene, I could have like a scene, I could put it into memory basically. I could put duplicates into a set or a, that would be the place to put them. You wouldn't want to put them into a list and iterate over that. Would you want to put them into a hash map? You could, but that kind of, like the purpose of a hash map where the value is just like 1 or 0 for scene, that's like the same purpose as a set. Serge says, when I submit any solution more than one time, then shows different beats of different memory. Can you tell me why? Yeah, it's just random variation. There's just thread-wise random variation. You should not get major swings, although that can vary too. Depending on like load on the server and stuff like that. So maybe if you can pinpoint the lowest traffic time of day for leetcode.com, you could game a slightly better score. None of that stuff matters though for interview purposes because we want the asymptotic worst case time complexity and space complexity. So the number of milliseconds don't matter. When you're thinking too much about millisecond differences instead of the asymptotic time complexity differences, those we tend to put in the bucket of micro optimization. There are some real world cases where it makes a huge empirical difference. So that's definitely worth talking about. And outside of interview settings, that's really, really important because maybe you can actually convert from a linear structure to a quadratic structure and it can actually be a speed up. empirically. Goofy stuff happens in the real world, but at interview time, don't get into all that. You're going to be wasting your interview time, basically. I mean, maybe there's a chance you'll impress the interviewer if you can talk intelligently about those cases, but usually it's going to be just a waste of your time. All right, cool. So this is going to be my final solution for today. It took us about an hour to get 2 solutions, which is not optimal. We're taking too long, and we saw some mistakes I made along the way, right? What are some of the mistakes I made? One is I waffled on whether I should go for no sort or the sliding window 2-pointer method. It's not really a sliding window because you're going inwards. So it's 2 pointers, sliding window, you would be moving across, whatever. So I waffled, and that was a mistake. That cost me some time. 2, I envisioned the wrong implementation. I envisioned doing the 2-sum in band. So I mixed up the mental model of the no sort and the 2-pointer. I mixed up the mental model. Big mistake. 3, I didn't handle the duplicates properly. 4, I missed the edge case of when the index is 0. And 5, I had to play around. I didn't realize immediately. I realized after a few seconds, but I didn't realize immediately that we always know the value order in the 2-sum context. So I don't need to sort. Because I was doing like tuple to list, back to tuple, back to list. And that was a time sink as well. So I think I easily could have cut out 15 minutes, and we can get under that 5-minute mark. So tune in next time. And it's just drill, baby, drill. Drill, baby, drill. LeetCode problems are your gateway to a big tech job in the same way that, I don't know, oil is like making big money. So it's drill, baby, drill. Maybe that kind of made sense in my head, but it was probably a terrible analogy. Thanks for being here. See you next time. Follow if you're interested in coding material. And once again, we have been dealing with the Latterly LeetCode kata, available free on the Latterly blog, article number 3. And I encourage you to sign up, join the Discord under the community tab. Join the Discord under the community tab. And also you can support the channel as little as $1 a month. You'll unlock access to the advanced checklist. It's going to accelerate your job search, and you can book a one-on-one consult with me if you're interested. Talk to you later. Yadi, do you need to do interviews in JavaScript or Python? It depends on the company. But many of the big tech companies will let you pick the language of your choice. Usually in tier 2 companies, they will want you to have a specific language because they'll be hiring for, say, like specifically hiring for a React developer, and then you wouldn't want to interview in Python, right?